Happy afternoon to all of you. Welcome to the VCC and a very good afternoon. I think you're all settled down for the second session. And this time we are left with little bit of important areas from the matrices chapter, and then we shall move on to linear inequalities. So today what I'll be doing is I'll break up the session into two parts. First, we will take up the remaining areas of matrices. That is, we will look at determinants once again, Gramos Rule in three unknowns, that is X, Y, and Z, adjoint of a matrix, cofactor of a matrix, and inverse of a matrix. We will do some examples, exam questions, and then we will move into linear inequalities, right? Now, in the last day, friends, we had done a huge area, and I started with introduction to matrices, and you remember that matrix is nothing but a rectangular array of numbers, and the plural of matrix is matrices. It is nothing but a table of numbers, a tabular representation, and it has a wide-ranging application in the field of business, economics, projection of sales, costing data, and financial management. So we discussed about the order of the matrix, which is m into n, which talks about the number of rows and the number of columns. Then we discussed about equal matrices. I talked about how to carry out, how to do the transpose. Given a matrix A, how to find AT, A transpose. Thereafter, we had talked about the row matrix. I discussed about column matrix, zero matrix, which is also known as null matrix. After that, we differentiated between what is a square matrix and a rectangular matrix. So when the number of rows is equal to the number of columns, we call it a square matrix. It can be 2 by 2, 3 by 3, 4 by 4, and so on. But in case of a rectangular matrix, the number of rows will not be equal to the number of columns. Thereafter, I think you remember, we discussed about diagonal matrix. From diagonal matrix, scalar matrix, where all the elements on the principal diagonal are equal. And when this number is equal to 1, then we call it a unit matrix. So please remember, once again, the relationship, the interlinking, the relationship between diagonal matrix, scalar matrix, and unit matrix. Then, of course, we cannot forget two more important principles, concepts. One is upper triangle matrix and the other is lower triangle matrix. Thereafter, submatrix, you remember I gave the example of a cake and asking for a piece of cake. So submatrix is obtained by blocking any particular row, any particular column, or both row and column. Then symmetric matrix and skew symmetric matrix. Quick recap, symmetric matrix means what? If a matrix is such that is equal to its transpose, then we call it symmetric matrix. And when the transpose is the negative of the original matrix, then we call it as a skew symmetric matrix. And then we discussed and did a number of examples on addition of matrices and subtraction of matrices, which is basically the algebra of matrices. Now we also did scalar multiplication. And today we will do one more example on multiplication of matrices. Thereafter, you remember we discussed about determinants, and determinants of 2 by 2 we did. And then we did few examples on 3 by 3 matrix, how to find the determinant for a 3 by 3 matrix. Finally, we closed with Gramos Rule, which is an easy and effective way of solving linear equations. Last day, we talked about how to use Gramos Rule for solving two unknowns, X and Y, and we did several problems. Today, we shall solve problems with three unknowns, X, Y, and Z. So I hope you have your pen and paper together, you are refreshed, and let's get going. Now, first, friends, today we will take up the multiplication, the issue of multiplication of matrices, and we shall see whether two matrices A and B, right? If we have A and B, is it equal to B A into B, is it equal to B into A? So we shall try to see this. Now I'm taking two matrices, very easy matrix, 2 by 2 matrix. I'm taking A equal to 6, 3, 2, and 5. So please do the problem with me. 6, 3, 2, and 5. And I'm taking B, matrix B, as -3, 2, 1, and 5. Now what I'm going to do is I have got two matrices A and B. Both of them are square matrix, and they are of the order of 2. So we shall try to find out the product of the two matrices. Let me see if we can do the product. We can work out the product together. Okay, so here we go. A into B will be equal to 6 into -3, that is -18, plus 3 into 1, that is 3. Friends, you may remember clearly that in the last day, when we were doing the product of two matrices, I talked about the approach. The approach will be here horizontal, and here it will be vertical, right? And you remember we discussed about the point that the number of columns in the first matrix must be equal to the number of rows in the second matrix. Otherwise, multiplication is not possible, right? So therefore, we look at this process, and let us see. 6 into -3 gives me -18, plus 3 into 1 is 3. So I have done the multiplication of row 1 and column 1. Now I will take up row 1 and column 2. So 6 into 2, that is 12, plus 3 into 5, that is 15. Thereafter, friends, I'm taking row number 2 and column number 1. So 2 into -3, that is -6, plus 2 into -3, that is -6, plus 5 into 1, that is 5. And now I'm taking row number 2, column number 2. So 2 into 2, that is 4, plus 5 into 5, that is 25. Let us see what result it provides us. So the answer, I'll write it here, is -18 plus 3, that gives me -15. 12 plus 15 gives me 27. -6 plus 5 gives me -1. And 4 and 25 provides us with the number 29. So this is, remember, please, that this is the product of A into B. Now, I will keep the answer here it is, as it is, but we will do B into A. Okay, we will do B into A. So I will just rub out some parts and just write B into A. B into A. So instead of A here, I will write B. I will write B. And instead of B here, I will put A. And of course, I will change the values. So -3, 2, 1, and 5. So I will make this -3, 2, 1, and 5. And in place of A, what I will write is, what is A equal to? 6, 3, 2, and 5. 6, 3, 2, and 5. Friends, I hope you're following what we are doing. We are just trying to see whether A into B equals B into A or not, right? So 2 into 5 is 10, 5 into 2 is 10, right? 6 into 7 is 42, 7 into 6 is 42. But whether in the case of matrices, A into B, does it give B into A? That is something we are finding out, right? Okay, so B into A we will do now, and this time it is -3 into 6, right? So it is -18, -3 into 6, that is -18, plus 2 into 2, that is 4. This is column 1, row 1, column 1. Now we will do row 2 and column 2, okay? So row 2, -3 into 3, that is -9, plus 2 into 5, that is 10. Thereafter I'll take up column 1 here, but I will take row number 2. So I did row 1, column 1, row 2, column 2, row 1, column 1 here, row 1, column 2 here. Now I will take row 2, column 1 here, and row 2, column 2 here. Okay, so let me work out row 2 and column 1. 1 into 6 is 6, plus 5 into 2 is 10. And row 2, column 2. So 1 into 3 is 3, plus 5 into 5 is 25. So what do we get? Minus 18 plus 4 gives me minus 14. Minus 9 plus 10 is 1. 6 plus 10 is 16. And 3 plus 25 is 28. So please see, dear friends, that we are not getting the same matrix as this one. So A into B gives us this matrix, minus 15, 27, minus 1, 29, but B into A gives us minus 14, 1, 16, and 28. So we note a very, very important rule, that is A into B is not equal to B into A. Okay, so I hope you followed. Matrix A into matrix B is not equal to matrix B into matrix A, and this is something we did through the example. Okay, now I'll take one more example of determinants, right? And as I complete each and every point, we will move closer to inequalities. Inequalities is a simple chapter and a small one, short and sweet chapter, nothing much to worry. Based on your knowledge of equations, we can easily deal with inequalities, and there will be some graphical work we will do. I am taking one example which came in the exam, determinant of a 3 by 3 matrix, and let me see if we can work it out. The matrix is 2, let me check, 2 minus 3, 1, 2 minus 3, 1, 2, 0 minus 1, 2, 0 minus 1, and 1, 4, 5. 1, 4, and 5. You have pen and paper, and I'm sure you are working it out, and let us work it together. Fine. So what to do here? First, we take the first number, row number 1, column number 1. So I will take 2, okay, and then what I'll do is I will consider this particular part because I have blocked these two. So what I will do is I will take 0 into 5, that is 0, minus of 4 into minus 1. Minus of 4 into minus 1 is plus 4. Okay, so please look at the sign. 0 into 5 is 0, minus 4 into minus 1, that is minus of minus 4. Okay, this is the first part. Now I will take 3. Okay, I was supposed to take minus of minus 3. But I have directly jumped one step and written plus 3. I hope you can now follow. Minus of minus 3, it becomes plus 3. So this time we will take 2, 1, minus 1, and 5. So the calculation will be like this. 2 into 5 is 10, minus 1 into minus 1. 10 minus 1 into minus 1, that is 10 minus of minus 1, that is 10 plus 1. So 10 plus 1. Plus the last digit 1. So I will block this, and I will take 2, 0, 1, and 4. So 2, 0, 1, and 4 means 2 4s are 8, minus 1 into 0, that is 0. So let me work it out and see what do we get from here. So 2 into 0 plus 4, that is 8, plus 3 into 10 plus 1, that is 33, plus 1 into 8 minus 0, that is 8. So I'm getting 33 plus 8, that is 33 plus 16, which gives me 49. I think some of you might have also got the same answer, right? 49. Good. So we did one determinant, and I just strike through as and when we complete the parts. Friends, now it is time to get into the next point, and that is we will talk about the Gramos Rule slowly, and we will take the Gramos Rule for 3 unknowns. And let me do one more quick solution on Gramos Rule with 2 unknowns, and then we will move into 3 unknowns. Okay, this is something we have not done last day. This is also an exam question. 7x plus 3y equal to 15 and minus 2x plus 5y equal to minus 16. Okay, please see the equations and let us see if we can work it together. 7x plus 3y equal to 15 minus 2x plus 5y equal to minus 16. Let me work it out. So we know the relation x, y I will put here, and I will create the necessary determinants. We know that x is equal to dx by d and y is equal to dy by d. So what will be d equal to? D is equal to the coefficient of x, the coefficient of y, and then the constant. So it will be 7, 3, and of course 7 and 3 here it will come, and minus 2 and 5, minus 2 and 5. So 7, 3, minus 2 and 5, this will be d. Here also we have the same values, 7, 3, minus 2 and 5. So 7, 3, minus 2 and 5, I write the same numbers, 7, 3, minus 2 and 5. So now we go to dx. Dx, as we know, is what to do with dx. Instead of the coefficient of x, we will put 15 and minus 16. So instead of 7, I will put 15. This 3 will remain as it is. So 3 remains as it is. Instead of minus 2, I will put minus 16. And instead of this we have done, and 5 will remain as it is. This is dx. Now, friends, we move to dy. The same rule applies, and 7 and minus 2 remains as it is because they are the coefficient of x. But instead of 3 and 5, we will put 15 and minus 16. Okay, so let us see if we are getting the right answer, and let's work it out. So this by this. Okay, let me first work out d. D is equal to 5 7s are 35 minus of 3 into 2, that is minus 6. That is, it gives me 35 plus 6, that is 41. Right, I am getting 41 as the value of d, which is the determinant here, and it is the denominator as well. Now let us find what is the condition here. So we had 15 minus 16, 3 and 5. So this is 15 into 5, that is, now we are working on dx. 15 into 5 is 75 minus 16 into 3, that is 48. But this is minus 48 because we have minus 16 here. Therefore, what to write here? 75 minus 48. So this gives me 75 plus 48. I think we are getting 75 plus 48. Quickly do it. I think we are getting 123. So I am writing 123. So what is the value of x? X comes to the numerator, which is 123, divided by the denominator, which is 41. Does 41 go into 123? I think yes. 41 3s are 123. So I'm getting the value x is equal to 3. Great. Now let's work out dy and see if we can get the value of y as well. So y, yes, the denominator itself is 41, but let's look at the numerator. 16 into 7, 112. So, but this is negative, so I will write minus 112 minus of 15 into 2, that is 30. But we have minus of minus 30, so it will become plus 30, right? So it becomes plus 30. So I'm getting minus 112 plus 30. How much is that? That is minus 82. So I'm writing minus 82, and the denominator is 41. 41, does it go in 82? Yes, 2 times. So we get -2 as the answer. So y is equal to -2. So the solution is x is 3 and y equal to -2. Right? So I think we are even more clear in terms of how to use Gramos rule for 2 unknowns. And now we will go into 3 unknowns and see if we can solve it properly. This is an interesting part and the toughest part in matrix chapter. Okay, Gramos rule, and that also with 3 unknowns. But we will do it with your sustained cooperation and by following clearly the steps. I am sure we will get it done and we will understand the process. So I am now taking up Gramos rule X, Y, and Z, and I'm cutting it. This is the agenda we had. One by one we'll do, and then we will eliminate each of them. Now, the rule, friends, remains the same. Gramos rule for 2 unknowns and 3 unknowns remains the same. We again have to find determinant D, which will go to the denominator, and the basic rules remains the same. So I am taking an example, 2x, let me write it up, 2x plus 3y minus z equal to 1. Then we have 4x plus y minus 3z is equal to 11, and 3x minus 2y plus 5z equals 21. Let me check the problem once again. This is an exam problem, and it also came in the MTP model test paper. So very, very important for your exam. 2x plus 3y minus z is 1. Okay, please note the problem. 4x plus y minus 3z is equal to 11, and 3x minus 2y plus 5z equal to 21. So we have to find here 4 determinants. In case of the last example where we had 2 unknowns, x and y, we were dealing with dx, dy, and d, right? So 3, dx, dy, and d. But this time it will be dx, dy, dz, and d. So a little bit of more work I'll request you to put in, little harder work, and we will solve it together as usual. So let me first try with d. So d is the same concept, just put the coefficient of x, y, and z as it is, nothing to worry. So I will write for d, I will take 2, 3, and minus 1. 2, 3, and minus 1. 4, 1, and minus 3. 4, 1, and minus 3. 3, minus 2, and 5. 3, minus 2, and 5. Okay, let us see what it gives us. So let's work on this and see what it gives us, what result we get. This determinant is equal to, I will take 2. Okay, this time I will also request you to solve the problem with me step by step. And as I said, the more the number of times you practice, especially tricky ones like matrices and determinants, because many of you are doing this chapter for the first time, and this is not a very common chapter which you have done earlier in mathematics. At the same time, this is a very scoring paper, and this chapter itself is very scoring, because if you know the determinants principle and matrices principle, there is no way to lose marks, right? You definitely get full marks. So let's do let's do together. And as I said, always remember one point: be careful about the sign change, and especially minus of minus gives you plus. Please don't forget that. And second is, be very calm and cool when solving these problems, so that you don't make silly mistakes and unintentional, of course, mistakes, right? So I'll take 2, and I will take 1 into 5, 5, minus 2 into minus 3. Minus 2 into minus 3 is 6. So 5 minus 6. Minus 3 into 4 into 5, that is 20. Minus 3 into minus 3. 3 into minus 3 is minus 9. Minus of minus 9. So it becomes plus 9. Okay. Then we have minus 1. So I write minus 1, and I will take 4 into minus 2, that is 8, minus 8, minus 3 into 1, that is 3. So what am I getting? 2 into 5 minus 1. 5 minus 1 is minus 1. Minus 1 into 2 is minus 2. Then I have minus 3, and here we have 20 plus 9, that is 29. 29 into 3 is 87, I think, right? So I will write minus 87. 29 into 3, right, 87. Then I have minus 1 into minus 11. So it becomes plus 11. So what I'm getting is minus 87 minus 2, that is minus 89 plus 11. So minus 89 plus 11, that is minus 78. So please remember that we are getting the value D, determinant D, as minus 78. Now we have to work on dx, dy, and dz. So I will rub this part because I will use it for solving dx, dy, and dz. I just write here d is equal to minus 78. Okay, and I move forward with the next part of the solution, which is finding out dx. So now dx will be what? The same principle, friends, nothing to worry, no change, no new concept, it's just the same. Instead of the coefficient of x, we will put these constants. So this determinant dx will be 1, 11, 21, 1, 11, 21, and the same will be there. So 3, 1, and minus 2, so 3, 1, and minus 2, and the coefficient of z, minus 1, minus 3, 5. Minus 1, minus 3, and 5. Right? So this is a bit of hard work. I can understand compared to the determinants and the Gramos rule with 2 unknowns. This is a bit more hard work, but I know you will do it with a smile, right? Because mathematics is interesting, and the more brain work, the more number of calculations you do, the brain becomes sharp and sharper. Okay, so let's work it out and see. So here again, I take 1, then I have 1 into 5, that is 5, minus 2 into minus 3, that is 6. Then I take minus 3 here, and 11 into 5 I will take. So 11 into 5 is 55, 11 into 5 is 55, minus 21 into minus 3. So this becomes 21 into plus 3. So 21 3s are 63. This is what I'm getting. Then I have minus 1 here, so I put minus 1. 11 into minus 2, that is minus 22, minus 21 into 1, that is 21. So let me see what it leads us to. 5 minus 6 is minus 1. Minus 1 into 1 is minus 1. 55 plus 63, how much is that? Let me work out. 63 and 55, so this is 818. 118 I have got here. 118 I have got here, please see, 118 and multiplied by 3, okay? So 118 multiplied by 3, this gives us 354, just check. So minus 3 into 118, so it gives us minus 354. And then I have minus 1 into minus 22 minus 21, that is minus 43. So this is minus 1 minus 354 plus 43, because this minus and minus becomes plus. So I should be getting 354, 355 plus 43, that is I should be getting minus 312. Just check and see. I think we are getting minus 312. This is dx. Okay, and let me write dx here. So dx is minus 312. This is something we have done together and did each and every step. Now I rub it up, and it is time for finding out dy. Okay, I hope you're following and it's clear to you. Step by step we are doing. We have first done the determinant d, okay, which is the denominator. Then we have solved dx, and now we take up dy. Okay, so dy is equal to 243. The coefficient of x remains as it is, but instead of the coefficient of y, we will put the constants. That is 1, 11, and 21. We will put here. So it will be 1, 11, and 21. And the remaining part, that is for z, it will remain as it is, -1, -3, and 5. So let us see whether dy construction is correct. We have 2, 4, 3, 1, 11, and 21, -1, -1, -3, and 5. Right? So now we are set to start with the computation and to see what it gets us to. Yeah, Pooja, we will take adjoint and inverse matrix after this. It's written one by one. I will complete the chapter thoroughly as we are doing with each and every chapter, and then I'll move to inequalities. Don't worry. Okay. Ananya, thank you. You have got -312. Good. So many people are working with me. It's great to know that we are scattered throughout the globe, but we are working together on the same problem, thanks to the magic of information technology. Okay, so let's work this out. And this is 2, 11 into 5, that is 55, minus 21 into -3, minus of minus, so it becomes plus 63, -1, -1, 4 into 5, that is 20, -3 into -3, -3 into -3, that is -3 into -3 is -9, so minus of -9, so this becomes +9. Then I have -1 here, -1, 4 into 21, that is 84, -3 into 11, that is 33. So 55 and 63 is coming to 118 into 2. Okay, 118 into 2 is how much? 236, if I'm not mistaken. 236. Then I have -20 plus 9, so -29. And then I have 84 minus 33 is how much? 84 minus 33 is 1 and 5. So 51. So I have -51. So this gives me 236 minus 29 minus 51. So this is 236 minus 80. 156. This is what I'm getting. So dy, I'm getting 156. I will write dy equal to 156. And I will rub this part so that we can carry on with the last computation, and that is dz. Yes, many of you might be wondering that, oh my God, this takes so much of time. But yes, I'm explaining step by step. I'm also doing slowly. I'm stopping and trying to show you where the sign is changing, right? When I'm calculating the determinants. In the exam, of course, you don't have to show anyone. You don't have to teach anyone. You just go on doing as fast as possible. But yes, these questions do come. Similarly, adjoint and inverse, they do come. So I will request you very humbly to please complete. That's why I'm taking the time, the extra time, because we had completed matrix as per the schedule given, but I am taking extra time here today so that we can cover each of the chapters, and we may have to extend beyond 4 o'clock today so that we can complete inequalities, right? So these are very important, and these 3 are based on determinants, right? So let us do dz now. Dz, and dz will be, the determinant is 243, 243, 3, 1 minus 2, 3, 1 minus 2, and instead of the coefficient of z, we shall put 1, 11, 21. 1, 11, 21. Just check if I've done correctly. 2, 4, 3, 3, 1 minus 2, 1, 11, and 21. Okay, now it is time to work it out together as usual. So I'll take 2 first. 1 into 21, that is 21, minus 11 into minus 2, that is minus of minus 22. So that becomes plus 22. Minus 3 multiplied by 4 into 21, that is 84, minus 33. 11 into 3 is 33. Plus 1, this one. And now I will take 4 into minus 2, that is minus 8, minus 3 into 1, that is 3. Okay? So I hope it's clear step by step, right? And this is, of course, friends, once again, one of the complicated and complex steps in mathematics, and matrix is not a joke. This chapter is a serious chapter, and as usual, lot of in-depth calculations are being done. And once, if I lose my cool, or if I sort of just lose control over what I'm doing, and if I'm distracted, I'll make a mistake. So make sure when doing it under speed, under exam conditions, exert your self-control, be aware of what you're doing, and follow the signs, especially the minus and plus signs, very, very carefully. Okay, so we are now dealing with the last part. 22 and 21 is 43. 43 into 2 is 86. Minus 3 into 84 minus 33, that is 51, I think. And then we have minus 11 into 1, that is minus 11. So I have 86 minus 51 into 3, that is 153 minus 11. How much does that get us? So it is, I think, 86 minus 164. So 86 minus 164. So I think that is minus 78. Right? I hope you have done correctly. dz equal to minus 78. Now we are done, and we now quickly find out the values of x, y, and z. We have got the values of the 4 determinants, and therefore we can comfortably and confidently declare the values to everyone. Okay, so x is equal to dx by d, that is minus 312 by d is minus 78. Minus minus cancels. 78, how many times it will go into 312? I think it will go 4 times, right? So that is 4. Great. Y is equal to dy by d. dy is 156. So I write 156 by minus 78. And this is minus 2. And we have z, which is dz by z. Dz by d. And this is dz is minus 78. So minus 78. And d is also minus 78. So this gives us 1. So the answer, my friends, is x is 4, y is minus 2, and z is 1. I really hope that it's clear to you. We have done it slowly, step by step, and we have reached the solution of the determinants, how to use determinants. And of course, this brings us to the end of Gramos Rule. Now we go to adjoint, right? And we take up adjoint, the last part, adjoint, cofactor, and inverse. So we are moving in a logical and systematic way, and making sure that now we take up adjoint. I strike it out. Now, what is adjoint? Adjoint of a matrix, just note this point, friends. Adjoint of a matrix, let me write the definition and then we will understand the concept. The adjoint of a matrix is the transpose of the cofactor matrix. Okay, let's understand this. Okay, and I think the best way to understand, if you write adjoint of a matrix A, so we write it as like this: ADJA, adjoint of a matrix A. Okay, so the best way is to do a problem maybe from the exam, or maybe, yeah, many of you have got the answers correct. Great. Ritik, Anjali, Gaurav, Jaya, Priyanshi, Sejal, very good. Excellent performance. Good. Now, adjoint A. Let's take an example and see. This is from the study material, page 2.48. I think you have the problem with you, 2.48. And let me take the example. Now, A is given, A is equal to 140. Okay, 140 minus 1, 2 and 2, minus 1, 2 and 2, and 002, 002. Now we are supposed to find the adjoint of A. Adjoint of the matrix A is the transpose of the cofactor matrix. So we first need to know what is cofactor and how to find the cofactor. Okay. Now let us try and find the cofactor. Okay, listen, please listen very carefully and please follow as intently as possible with full concentration, even though it is the second half, but you have to keep alert and be sharp and follow each and every step which I'm doing to understand the entire process. Okay, so we will take the cofactors, and let me see, I will write the cofactors. A11. A11 means the calculation will be like this: minus 1 to the power 1 plus 1, because I'm taking cofactor 11, A11. So I'll write 1 plus 1. And I will find the determinant of which one? I will block this 1 and 1. So 2202. So I will write 2202. I'll find the determinant. So this is minus 1 square into 2202. So it's how much? 2 2s are 4 minus 0. So 4 minus 0 is 4. Minus 1 square is plus 1. So plus 1 into 4 is plus 4. I have done A11. I will do the next cofactor A12. The formula will be very simple. Put minus 1 here and to the power 1 plus 2, because this is cofactor A12. So 1 plus 2. So I will take, I'll slash this out, and 2, I'll take this out. I'll have minus 1, 2, 0, 2. Minus 1, 2, minus 1, 2, 0, 2. Okay. And this, if you see, will give us minus 1 to the power cube, minus 1 to the power 3. That is minus 1 into minus 1 into minus 1. That is minus 1. So it is minus 1. This one gives me, this determinant gives me minus 1 into 2, that is minus 2. Minus 2 into 0, that is 0. So I get minus 2. Minus 1 into minus 2 is 2. Okay. In this way, if you carry on, this is A11, A12, A13. Then you have to take A21, A22, A23, A31, A32, A33. Okay. Let me take A33 as the last example. A33. A33 means minus 1 to the power 3 plus 3. 3 plus 3. What will be the determinant? A33 means the third row is gone, the third column is gone. So I will write minus 1, 2, 0 and 0. Minus 1 to the power 6, that is minus 1 to the power 6 is 1. But here we have minus 1 into 0, minus 2 into 0, that is 0. So A33 will be 0. Okay. So what we get is, if you write the cofactors now, right, we will get the cofactors in this way. If you see the numerical which is given, the example which is given. Now I will write the cofactor and then we will do the transpose. So cofactor of A, right? Cofactor of A is coming to, we got the numbers, I have noted the numbers here. So it is coming to 420, minus 820, minus 8, 2 and 0. Okay. Then 8, minus 2 and 6. This is the cofactor matrix of A. This is the cofactor matrix. The cofactor matrix. If you take the transpose of this matrix, you will get the adjoint, because adjoint of A is equal to the cofactor matrix and the transpose of that. So we have got the cofactor matrix here. If you take the transpose of this matrix, you will get the adjoint. So I will create the transpose. 4 will remain as it is. This 2 will remain as it is. The diagonal remains as it is. This 2 comes here, minus 8 goes up. So I'll write 2 here, minus 8 goes up. 0 comes here, 8 goes up. So I put 0 here and 8 is gone. It's gone up. 0 will come here, minus 2 will go up. So 0 comes here, minus 2 goes up. So we have got the answer 4, minus 8, 8, 2, 2 minus 2, 2, 2 minus 2, 0, 0, 6. Okay, so this is how we create the cofactor first, and from the cofactor we can get the adjoint, right? The way in which we do it, right? So in this way we have taken up the point of we did A13, A12, we did A11, A12, A13 we did. So we got 420, and then we got minus 820. Of course, these ones you can put it, you can put the values and see how we get it. And then yes, once we get the cofactor matrix, you just find the transpose and you can get it done. Okay, so always remember that whenever you have the cofactor matrix, I will take one more example and we will see how to complete this. This is from the exam, and let us see how we can get it done. The given problem is 1, minus 1 and 2. 1, minus 1 and 2. Then we have 406, 406 and 0, 1 and minus 1. You have to find the adjoint of this. And friends, with adjoint, we will cofactors we have discussed. I'll write it off. The last one is inverse. We will see the formula of inverse of a matrix. Let us first find out what will be the adjoint of this matrix. So the adjoint of this matrix will be the cofactor matrix and the transpose of that. Okay. So once again, for this matrix, let us work out on the cofactors. So first, let us take cofactor 1, 1, A11. Okay. So 1, 1 means we will just take minus 1, 1 plus 1, that is 2, and 1, 1. So 1 is gone, 1 is gone. 0, 6, 1, minus 1. So that is minus 1 into 0, that is 0, minus 6 into 1. So it is 0 minus 6. So I have minus 1 square is 1. 1 into minus 6 is minus 6. So A11 is we have got. I will take A12, right? A12. So A12, so minus 1, 1 plus 2. Okay. And A12. So A12 first row is gone and the second column is gone. So we will have 4, 6, 0 and minus 1. So the determinant is 4, 6, 0 and minus 1. Okay, I'm doing fast, so you can see that explaining and doing it simultaneously. So please pay attention and see how we are doing it. Minus 1 into to the power 3 is minus 1. This gives me 4 into minus 1, that is minus 4. Minus 6 into 0, that is 0. So I get minus 4. So minus 1 into minus 4 is plus 4. So we have got A12. Now I will take A13. Okay, A13 in this way. A13. A13 will be minus 1 to the power 1 plus 3. And the determinant is what? A1. I have taken A1. And 3, I am cutting this. So I'll be getting 4, 4, 0 and 0, 1. Okay. I will be getting for A13, I'll be getting 4, 0 and 0, 1. So 4, 0, 0, 1. Minus 1 to the power A13. Okay. So minus 1 to the power 1 plus 3. That is minus 1 to the power 4. Minus 1 to the power 4. 4 into 1 is 4 minus 0, that is 0. So this into 4. Minus 1 to the power 4 is plus 1. So plus 1 into 4 is 4. So we have got A11 minus 6, A12, 4, A13 is also 4. Let me write it somewhere, otherwise I'll forget. Okay, because I need to clear up the place for calculation. Let me rub out the last example here and use the space for writing. So cofactor A11 has come to minus 6. Cofactor A12 is 4. Cofactor A13 is also 4. Now we are left with 1 1 1 2 1 3, 2 1 2 2 2 3, 3 1 3 2 3 3. Okay, so let us do that and see the next steps. I'm doing each and every part of this problem so that we are confident and you can solve it yourself. Okay, so A1 1 1 1 2 1 3 is done. Now I'm taking up A21, cofactor of A21. So the formula is -1 to the power 2 plus 1, and the determinant we will take is A2, that is I will remove this one and column 1. So I'm getting 0 6 1 minus 1, 0 6 1 and minus 1. -1 to the power 3, 2 plus 1 is 3, so it is -1. 0 into -1, that is again -1. -6 into 1, that is -6. So I'm getting -1 into -7 plus 7. Okay, so this is, I think we have done. Just check once again, A21. Just I'm checking once again, A21. A21, no, we have taken the second row. Just a moment. I'll have to check it. No, there's a mistake here in this step. I'll just do once again. This crossing out creates a problem. Cofactor A21, -1 to the power cube. This is fine. I'm rubbing out this row and this column. So I'm getting these numbers 1, 2, 3, and 4. Yes. So it is -1, 2, 1, and -1. -1, 2, 1, and -1. Okay. So this gives us how much? Let us see. -1 to the power 3 is -1. And this is -1 into -1, that is +1, -2 into 1, which is 2. So I'm getting -1 into -1, that is 1. So this is confirmed. A cofactor 21 is equal to 1. So I will write A21 equal to 1. So you see, even one mistake here and there will create a totally wrong answer. Now we will do cofactor A22. Let us do it fast. -1 to the power 2 plus 2. Cofactor 2, 2. So 2 and 2 is gone. I will get 1, 2, 0, and -1. 1, 2, 0, and -1. Okay. 1, 2, 0, and -1. We are doing cofactor 2, 2. This gives me -1 to the power 2 plus 2, that is -1 to the power 4, that is +1. And here I have 1 into -1, that is -1, -2 into 0, that is 0. So I get -1 into 1, which is -1. Okay. So cofactor 2, 2. We are getting -1. I will write A22 equal to -1. Right. Hope you're following, and you can see that this is not that easy because this takes some time, and you can see that each and every step has to be done carefully. Cofactor A23, the formula is -1 to the power 2 plus 3. Okay, some of you are asking, this is the formula, you don't have to go into the derivation, just remember the formula is -1 to the power this plus this, I plus j. Okay, so A23, this is the formula, keep -1 to the power 2 plus 3. We are doing A23. So the second column is gone and the second row is gone and the third column is gone. So I will get 1, -1, 0, and 1. 1, -1, 0, and 1. This will give me -1 to the power 2 plus 3, that is -1 to the power 5, which is again -1. And the determinant will be very simple, 1 into 1, that is 1, minus 0, so 1. This is -1. So cofactor 2, 3, cofactor number 2, 3 is -1. So I will write 2, 3 is -1. So this is not the end. We have to go to the 3, 1, 3, 2, 3, 3 part, and then we shall be getting the entire cofactor matrix. Okay, so now I will take cofactor A31. We have got 11, 12, 13, 21, 22, 23. We are left with 31, 32, 33. Okay, So now I'm taking up cofactor A31, formula being -1 to the power 3 plus 1. Okay. And what is the determinant? 3, 1. So I will block row number 3, column number 1. So I will get -1, 2, 0, and 6. -1, 2, 0, and 6. This will give me how much? -1 to the power 3 plus 1, that is 4. -1 to the power 4 is +1. So I will write +1. And this is -6 into -1 into 6, that is -6. 2 into 0 is 0. Doesn't make a difference. So we get -6. So cofactor 3, 1 is -6. I will write here A31 is -6. I request you also to keep on writing so that you can form the matrix after this. We move to cofactor A32. The formula -1 to the power 3 plus 2. Okay, the same formula 3 plus 2. What will be the determinant? Quickly. 3 plus 2. So third row is gone and the second column is gone. So we will get 1. Third row is gone. Okay, third row and the second column is gone. So we get 1, 2, 4, and 6. Okay, 1, 2, 4, and 6. We are doing 32. 1, 2, 4, and 6. -1 to the power 3 plus 2. That is -1 to the power 5. That gives you -1. So it is -1. 1 into 6 is 6. -4 into 2 is 8. So this is -2. So -1 into -2 is +2. So I will write A32. Okay, cofactor A32 equal to 2. Right. Now the last one, the last part of the cofactor A33. Okay, so cofactor A33. This is -1 to the power 3 plus 3. And this third row is gone, third column is gone. So we are having 1, -1, 4, 0. Determinant is 1, -1, 4, and 0. So you see in this problem, be very, very cool-minded. One slip of an attention, right? Of course, for me, it is easy to lose my attention because I have to do both the things, explain you step by step, speak, as well as do the problem. And I'm not copying it from any book or from any given study material. I'm just checking the question and then solving it out in front of you. But for you, please remember to give wholehearted attention, full concentration. Otherwise, you can see so many areas where you can make a mistake, right? -1 here again, while solving the determinant, there are, scope of making mistakes. So -1, 3 plus 3, -1 to the power 6, that is +1. 1 into 0, so I'll write 0. Minus of 4 into -1, that is +4. So 4 into +1 is 4. So finally, we have got A33 as 4. Okay, so now we are in a position to write the entire cofactor matrix. So now we rub it out and we write the cofactor matrix as per. So how many we did out? Just see 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 calculations, right? So the cofactor matrix is equal to 11, 12, 13. The rule you know is IJ. 11, 12, 13, 21, 22, 23, 31, 32, 33. So 11, 12, and 13. -6, 4, and 4. Okay? -6, 4, and 4. I write -6, 4, and 4. Then we have 21, 22, and 23. 21 is 1. 22 is -1. And 23 is again -1. Okay? Clear? And then we have 31, 32, and 33. 31 is -6. I write -6 here. 32 is how much? 2. Okay. 32 is 2 and 33 is 4. 33 is 4. This is my cofactor matrix. So the adjoint of the matrix will be the transpose of this particular matrix. So cofactor matrix transpose. So the answer is -6 will remain as it is. This 4 will come here. This 4 will come here. 1 will go up. -6 will go up. the element on the diagonal will remain as it is. This -1 remains as it is. This -1 comes down. The 2 goes up here and 4 remains as it is. So as per my working out, I don't know whether I made a mistake or not, but my answer comes to -6, 1, -6, 4, 1, 2, and 4, 1, 4, 1, 4. Okay. This is how we create the adjoint, and this is the toughest of this chapter, no question about it. Now we shall see how to find, yeah, some of you have done it. Gunjan has done it. Okay. Yeah, Moksha, you are asking about singular matrix and non-singular. Nitin has done it. Ritik has done it. Okay. I'm not checking your answers, but you have written your answer. Shivangi. Okay. Srinivas, we are taking -1. This is the formula. When finding out the cofactor, -1 to the power I plus j. That is the formula. Good. Many of you have done it. Okay. Now we take singular matrix and non-singular matrix. Now, it's just a definition, we need to remember singular matrix and non-singular matrix. So, a singular matrix means any square matrix, just write singular and non-singular matrix. Otherwise, we are just left with one point, and that is inverse. I can rub this one also. We have done the working of this problem. Please practice adjoint and inverse as many times as possible, because finding the cofactor will take time. And from this chapter, you never know, a question might come or two questions might come, maybe one on inverse, the other is on adjoint. That means you have to do entire determinants, right? Okay. So singular matrix and non-singular matrix. Now, if we have a matrix A, okay, and if determinant of that matrix, if the determinant of A is equal to 0, then we call it a singular matrix. Okay, then it's a singular matrix. So we will call it singular matrix. Singular matrix. If determinant of A is not equal to 0, it can assume any number, positive, negative, etc., then we will call it a non-singular matrix. So let me take a simple example. Let me take a matrix S. Okay, let me take an easy one. Just let's take -1, 2, and let me take, okay, -3 and 6. Let me see what it gives us. -1, 2, -3, and 6. So this is a matrix. Okay, I will find the determinant. So determinant of S, -1 into 6, that is -6, minus of -3 into 2, that is -6. So I have -6 minus of -6, that is -6 plus 6, that is 0. I'm getting 0. So can I say that matrix S is a singular matrix? Yes, because matrix S is singular matrix because determinant of the matrix gives me 0. If the determinant of the matrix gives me any other quantity other than 0, positive integer, negative integer, right? Or it can be even fraction, right? So in such a case, it will be a non-singular matrix, right? So we have done singular and non-singular as well. Okay. Now, friends, we will take the last part of our discussion on this chapter. We have done the Gramos Rule, determinants. I have done one more example today with 2 variables. I have done 3 variables. Gramos Rule, we did the adjoint, 2 calculations. We did the cofactor matrix, and now we will go to the inverse, and I will strike the last point out. Right. Now, what is inverse? Okay, inverse is very simple. We will not have to work. Just remember the formula because we have done the entire working up till now. The inverse of a matrix is shown by A inverse. Okay, inverse of a matrix is written as A to the power -1. Okay, like inverse. A inverse is nothing but adjoint of A divided by the determinant of A. Adjoint we have seen. Okay, adjoint means it is the transpose of the cofactor matrix, and we have done the cofactor matrices till now. Just now we have done so many examples of cofactor matrices: -1 to the power 1 plus 1, A11, A12, A13, A21, 2223, A31, 3233. Okay, so from there we get the cofactor. You transpose the cofactor, you get the adjoint, and once you have the adjoint matrix, right, just find out the determinant of the given matrix. Divide it, you will get the inverse. Okay, so this is the inverse matrix, and the idea, there's a relation between inverse matrix and the original matrix. The original matrix into the inverse matrix will give the identity matrix. Okay. So this brings us to the end of our chapter on matrices, and almost 50% of the allotted time today is gone. You can see it's already past 3. Okay. Some questions. The values of X and Y. I didn't get the answer question. Thanga Pandi K from Tamil Nadu. Sir, can values of X and Y? I didn't understand the question. Yeah, can X, Y, Z be decibel in Gramos Rule is a question. Okay, I think that is the question you are asking. X, Y, Z in Gramos Rule, can it be a decimal? Yeah, it can be a fraction, obviously, right? It can be a fraction, which means a decimal might come. Of course, you will write in fraction. Okay, now we start with linear inequalities finally, and I rub the entire data, the points on matrix, and we go into linear inequalities, which is a simple chapter and not much of memorization is required. Friends, this chapter, we have basically 3 parts to it. The first is understanding of linear inequalities, which will be easy because you have already discussed and learned about linear equations, right? Second is there will be optimization problems, which we shall do. And the third is graphical solution to different inequalities. We will also do that. So there are 3 parts to this simple chapter. The first is construction of linear inequalities. The second is optimization problems. And the third is graphical solution to inequalities. Now, if you see the chapter objective in page 3.1 of the study material, it is clearly mentioned that you need to understand how to develop inequations from the given problem. Problem will give number of conditions. It will describe a scenario, right? Maybe a production case, maybe a sales case where you are given the cost or raw material and you know the production. So from there, you need to just form the inequation. That is the first type of problem which can be expected. The second is graphical representation of linear inequalities. And the third is, of course, finding the solution set, right? Or the feasible region in the graph so that it satisfies the conditions given in the problem. Okay, this is basically the chapter objective, which is there in page 3.1. Now, inequality is very simple. Now, if I just, draw the solution space, like this is the number system, number line. Okay, so we have 0 here, -1, -2, -3, and this goes to minus infinity. 1, 2, 3, 4. This way it goes to plus infinity. Okay, this is the sign for infinity, right? Goes on and on. Now, the solution, right, for x is greater than 0. So if I write x is greater than 0, right, so what will be the solution space? The solution space will be something like this. X is greater than 0. Please note, I am not writing x is greater than equal to 0. I'm just writing x is greater than 0. So I have a small gap here because it cannot touch 0. And I'll just draw a line like this. And x is greater than 0, which means that from here, this side, it goes on. Okay, this is the solution space. It can take any values, but it cannot touch 0. So there's a gap. Okay. Now, if I write, but this is an inequation. X is greater than 0 is an inequation. It is not an equation. Okay. So if I write x is less than equal to 0, x is less than equal to 0. So here it is either less than 0 or equal to 0. Okay, so I will take this point 0 and I will draw an arrow to the left hand side, like this, and it will be x is less than equal to 0. In this case, I put a gap here because x cannot be equal to 0 because the given condition is x is more than 0. But here x is less than equal to 0. That means either x can be 0 or it can be less than 0. So the maximum value it can take is 0. Okay. So let us take a simple example to understand, and very interesting. You will see some graphical representation which will remind you of your school days, the good old days of school. Probably 7, 8, or 9, you learned about these things graphical. You remember the graph paper you used to work upon, small graph paper and pencil, you used to draw straight lines, intersect. So it will take you to some years back in time. Now, let us try to create the graphical presentation of an inequation 3x plus y is less than 6. Okay, so we are having two variables, x and y, and the inequation I'm taking is 3x plus y is less than equal to 6. Okay. So what to do? So let me take this in this way. Let me first equalize if I want to draw a solution to this problem, right? This came in the MTP model test paper. So what to do is we first equate, right? We create an equation. So we know 3x plus y is less than equal to 6. So let us first modify it as 3x plus y is equal to 6. So I write it as 3x plus y equal to 6. Okay, clear? First, let us write the equation. The first step in solving inequality is to first link it to an equation, and then we will incorporate the condition of inequality later on, not now. So we have 3x plus y equal to 6. So I will write y is equal to 6 minus 3x. Okay, fine, cool, no problem. Okay, now friends, you know that a straight line in a graph, when you are drawing a straight line, now how many minimum number of points do you need to draw a straight line? How many minimum number of points? Let me see who answers first. How many minimum number of points do you need to draw a straight line? So we are trying to draw a straight line, linear inequation. Okay, how many minimum number of points is required to draw a straight line? So we need 2 points, minimum 2 points. Okay, so we will try to identify the 2 points from this equation. You remember when I was taking the session on linear equation, I had told you that y, 3x plus y, this type of equation is called linear because I said that it can be drawn, it can be represented on a graph as a straight line. But when you have a quadratic equation, it will not show a straight line. Quadratic equation, you remember, one which has 2 roots. Okay, so it will assume it will not be a straight line. It might be a parabola. Okay, it will be a curvilinear line, curve, but not a straight line. This is a linear equation. So it can be represented as a straight line. So let me just do one thing. We draw a small table here. And this is the same thing which you also need to do. A simple table, I write x and y. Now, when x is equal to 0, what will be the value of y? Just check. If x is 0, then 3x is 0, so y will be equal to 6. Okay? So I find one line, 0, 6. Right? And the other condition is if y is equal to 0. So in the first example I took if x is equal to 0. But now if I write if y is equal to 0, then what will be the value of x? So if y is equal to 0, then 3x is equal to 6 and x becomes 2. Okay, so x becomes 2. So now I will draw the line, the vertical line and the horizontal line, trying to draw it as straight as possible. Okay, so we have the vertical line and the horizontal line. So x is 0 and y is 6. Please see the coordinates like you have the GPS, the global positioning system, latitude, longitude, right? These are global positioning system, right? So you can have three-way global positioning. You can have length, breadth, and height also, so that every precise point in the airspace can be defined. Similarly, here we have two dimensions, 0, 6. Okay, so 0, 6 means 0 means here, so it does not move. No movement in the x-axis, but 6 points towards the north. So 1, 2, 3, 4, 5, and 6. So this point is 0, 6. 0, 6. I've got 1 point. The other point is 2, 0. 2, 0 means I will move 2 points in the positive direction towards the x-axis. You know, this is the x-axis and this is the y-axis. So I move 2 points, 1 and 2. So this gives me another point, and this is 2, 0. And friends, I need 2 points to draw a line, as simple as that. Therefore, I've got my 2 points, and I will draw a line so that it cuts through these points. Let me see if I can do it like this. Okay, so this line is nothing but the equation y equal to 6 minus 3x. But the given problem, or you can write 3x plus y equal to 6. But the given inequality is what? 3x plus y is less than 6. Less than means towards the left. So the solution will be the shaded part, which I'm shading now. I think it's interesting for you and quite easy. This is the shaded part. This gives me the solution to the problem 3x plus y is less than 6. Okay. So if I can write, this is the x-axis and this is the y-axis. This line is the A and B. So the points, all the points which are below the line AB will be the solution to this inequality 3x plus y is less than 6. Okay. Now we will take an optimization problem from the study material and see if we can understand that and solve it. Okay, so I think this is clear, and you saw the steps we have taken is very simple. We have considered x and y. If a linear inequality was given, we first translated that into an equation. We tried to represent y as a function of x, and then we took this small table which you can see here, and I took the possibility, how to draw a straight line. Of course, yes, Jayashri and Kusuma, why is it 4 line? You need 2 points. 4, no, not 4 points. It needs 2 points. Vasudev, yes, 2 points. Bharani has said 1 point. No, 1 point you cannot draw a straight line, right? You need 2 points to draw a definite line. 1 point, if you have, you can have infinite number of lines, but you have 2 points, only 1 line can pass through. Okay, so you need 2 points. Okay, now, yes. So Mohak, you are not able to understand. Let me see. Once again, let us see. So 3x plus y is less than 6. This is an inequality. Okay, so if you take, just for example, if you take x is equal to 1 and y is equal to 1, then 3x plus y will be 4, and that is less than 6. So it is it holds good for x equal to 1 and 1, right? So now x equal to 1 and 1, if you see, if I write x equal to 1, y equal to 1, Mohak is from Indore, so you will now understand. I'll give you a very simple concept. If x is equal to 1, y is equal to 1, will this inequation be correct? So if you put x equal to 1, you have 3 into 1 plus y. So I put 3 into 1 plus 1, that is 4. And 4 is less than 6. So the inequation holds good. Now, graphically, if I put 1 and 1, x is 1, y is 1, that means the coordinate is 1, 1. Where will the coordinate be? 1 and 1. It will be somewhere here. Please see that this red dot which I've drawn falls within the blue shaded area. Please see this. This red dot which you find is the coordinate 1, 1. Like GPS, I said, every place on the earth can be precisely located with a GPS. Latitude, longitude, right? Similarly, this is like this. Every point can be located. So if you take x is equal to 1 and y is equal to 1, that means 3x plus y gives you 4, and 4 is less than 6. So for x equal to 1 and y equal to 1, the given inequation is correct. It holds good. Graphically, if you want to prove it, just in this graph, you take x, you see this line is what? This point is what? This point is 2, 0. So 1 will be somewhere here. 1 is here, I take 1 here. This point which I have drawn in red color, I have marked in red color, shows 1 and 1. Please see this is within the shaded area, which means it falls within the solution set for the inequation, right? I hope now you are clear and you have understood. Yes, so this is an unbounded graph because there is no limit, unbounded, there's no boundary here. We will see some bounded graph also, right? So, yes, Supradha Bhargavi from Chennai, this is an unbounded graph, yes. Well, the shadow part, Hetvi from Gujarat, the shadow part, that means this shadow part is nothing but the solution to the inequation 3x plus y is less than 6. It can have multiple values, okay, right? So if you take, for example, x is equal to, say you take x is equal to 0 and y is equal to 4, it will be less than 6. If you take x is equal to 0, y is equal to 2, it will be less than 6. If you take x is equal to 0.5, y is equal to 1.5, still it is less than 6. So it can have a wide number of solutions, and that is why we have a range, we have a shaded area, okay? Fine. Now we will do a study material problem, and this is from page 3.6, and let me take the optimization problems now, and then we will come back to graphical problems once again when we take the exam questions. Okay. So this is this chapter, you know, is a concept-based chapter. The last chapter which we did on matrices, from order of the matrix to adjoint and to inverse, I think you understand it was hard work on our part. That chapter is more of, you know, definitely concepts are there, but it is based more on understanding of terminology, understanding the difference, like singular matrix, right? Scalar matrix. So different terms you have to understand. But here you already know the terms. Here the idea is to put it graphically and to interpret using of intelligence, interpreting a given condition into an equation or an inequation or an optimization. Okay, so let me just take the example of optimization and see if we can understand this problem. This is from page 3.6 of the study material. This is the example which is wonderfully discussed in the study material. Now, a manufacturer produces two products, A and B. So I'm writing two products, A and B. And they have machines which can run for 24 hours in a day. So the machines can run 24 hours in a day. Fine, non-stop, 24/7, fine. Product A, the product A requires, there are two machines, M1 and M2, okay? And we have the product A and product B, okay? Please see carefully, right? So product A requires 2 hours of processing in machine M1. So product A, okay? You see what I'm doing? I'm reading the problem, understanding the problem, applying my brain, applying the logic and drawing it on the board, right? In a graphical manner, in a tabular manner, okay? This is basically what we have to do so for solving questions in this chapter, right? So we have product A. Now product A requires 2 hours of processing in machine M1. So I will write 2 hours in machine M1, and it takes 6 hours in machine M2. Fine, fair enough. It can take 2 hours in M1 and 6 hours in M2. Now, the second product, B. So product B. This requires how many hours? This requires 6 hours in M1 and 2 hours in M2. 2 hours in M2. Right. Now, the profit which is earned, the manufacturer is earning a profit. Fine. What is the profit? The profit is 5 units. So I'll write ₹5 for every unit of A. Okay. And the profit is ₹2 on every unit of B. So ₹2 per unit of B. The question is, how many units of each product should be produced in order to achieve maximum profit? So this is a question of maximization. Okay. So now I have product A and B. Right. So let me just introduce two variables here. So let me have two variables to understand the given problem. And okay. Let me take the number of units of product A. So I'm writing A, X, I'll take X1. So X1 units of product A, and product B, X2 units. Okay. So I'm producing X1 units of product A and X2 units of product B. Fine. Product A requires 2 hours. Okay. 2 hours of processing in machine M1. Okay. And 6 hours of processing in machine M2. Product B requires 6 hours of processing in machine M1 and 2 hours of processing in machine M2. And both the machines, please note, both the machines can run for 24 hours. Fine. Now, the profit is ₹5 per unit of A. So if X1 units are produced, then what will be the profit? The profit will be 5x1. X1 units of A are produced and X2 units of B are produced. So the profit will be, if I write profit is P, let it be P. So P will be equal to, what is the equation for the profit? ₹5 for 1 unit. So the profit for X1 units is how much? 5x1. So I write 5x1. ₹2 is the profit for producing 1 unit of product B, but I am producing X2 units of B. So the profit will be 2x2. So I will write 5x1 plus 2x2. This has to be maximized. This has to be maximized because the question is that you have to maximize the profit, but you have a constraint. There is a constraint in the problem. What is constraint? Constraint means limitation, right? Constraint. Let me write it here. Okay. Okay, I'll write it here. Constraint. What does it mean? It means limitation. What is the limitation here? The limitation here is that the machines cannot run for more than 24 hours. Okay, even if you want to produce, machine capacity is 24 hours. Number of hours in a day is 24. That is a constraint for all of us. We have to do time management within this 24 hours. Right? Similarly, time is, we are always in a race against time. So time is a constraint. Here, 24 hours is a constraint. Now, so we cannot just say that time is a constraint. We have to create an equation. We have to create sort of a mathematical expression to show what is the constraint. Now, let us try and think what can be the constraint. Okay. The product A requires 2 hours. So 1 unit of product A requires 2 hours. Okay. So if I produce X1 units of A, how much time will it take? 2x1 hours. Okay, 2x1 hours. Fine. Then product A also requires how much? product A requires 6 hours in machine 2. 6 hours in machine 2. Fine. So product A, 1 unit of A requires 6 hours in machine 2. So if I produce X1 units, I'm producing X1 units. Please see this, right? I'm producing X1 units of A. 1 unit requires 2 hours in machine A. So X1 units will require 2 X1 hours. I've written 2 X1. Similarly, in machine 2, how much time will it take? 1 unit takes 6 hours. So X1 units will take 6 X1 hours. So I will write 6 X1. Product A is over. Now it is time to deal with product B. Let us see the question of product B. Product B, I am producing how much? X2 units. Okay, I am producing how much? I am producing X2 units. X2. Okay, clear? Now product B requires 1 unit requires 6 hours. So X2 units will require how much? 6 X2 hours. Right? I think I'm correct in applying the principles, and I hope you can follow. Now, product B, 1 unit of product B requires 6 hours in machine 1, 2 hours in machine 2. So for X2 units in machine 1, the time taken will be 6X2. Here it is 2X1. Here it is 6X1. And X2 units for machine 2, each unit takes 2 hours. So X2 units will take 2X2 hours. 2X2. Please see if you are clear up till now. Right? Please see if you are clear up till now. Okay. Some of you are asking about the weighted marks. Yeah, Kamal Jain from Thane. Well, inequality, yes, 3 questions can be expected, right? 3 questions can be expected. I think I explained the weightage earlier, so it's around 5 to 10%. So 3 questions at least, right? So now you see, please focus on the problem. So we have the problem is product A and product B. Fine. A takes 2 hours. Each unit of product A takes 2 hours on machine 1 and 6 hours on machine 2. Product B, it takes 6 hours on machine 1, 2 hours on machine 2. And it is given that the manufacturer earns a profit of 5 rupees for unit A and 2 rupees per unit of B. What we have to do is we have to frame the maximization. Later on, I think in CA, you know, when we were students in CA, right, long back, more than 20 years back, right? So 25, almost 25 years now. So we had to study linear programming. That is an optimization problem. I think still now you have to learn it in CA final. So there you will learn a repetition of this chapter, but it will be more detailed, right? When you reach CA final, optimization problem and maximization problems, right? So here we are trying to maximize the profit, but the right word is optimization. Maximize means you just go on maximizing, more the merrier. But you see, think of food. You love food. Many of you are foodies. But can you maximize the food if, you know, huge amount of food is given to you? Say 10 pizzas given to you. Can you eat it? No, there's a limit. The body has a constraint. The body has a limitation. Okay. Yes, if I ask you maximize your study time, there's a limit to which you can study. Even if you have 24 hours at a stretch, can you focus for more than 3 or 4 hours? No. So we have to optimize. We cannot maximize in reality. Every company thinks of maximizing profit, more money, more profit, more revenue. Sorry, it cannot be done. Why? Because your raw material might not be available. You may not be able to run the machines for more than 24 hours. The people who are working in the factory, they require a rest. The machine cannot go on running. It will burst. It will burst into flames. There might be a short circuit. So you have to give adequate rest. So the ideal way is optimization. Optimize your time. Optimize your energy. Maximizing is not possible because we have constraints. If there are no constraints, you can maximize. Okay. So you see here, everything is fine. I'm assuming that the producer has a lot of money. He can buy as much of raw material as possible. But still, there is a limit, there is a constraint, because the machines can be used maximum for 24 hours. Okay. So here, what we have done is, we are trying to find the linear equation for the profit. He is earning 5 rupees per unit of A. So if I'm producing X1 units, the profit will be 5X1. This is for unit A. And for unit B, he is earning 2 rupees profit. So if we are having X2 units of product B, then the profit he will earn is 2X2. This is for B. I hope this is clear. So the profit equation is given by P equal to 5X1 plus 2X2. This we are supposed to maximize, but I will just cut this letter maxi and I will write here opti, so that instead of maximized, I will use the word optimize, not maximize. I've cut through the word maxi and I've written optimize, optimization problem, right? So there are constraints. So, what happens now is, we have got the profit equation. Now we have to find the constraint. Okay. The constraint, of course, is the timing. So now we are finding out if time is a constraint, if my watch is a constraint. See, we can go on discussing on mathematics so long as I can do it physically, mentally, and you can listen to it mentally and physically. But really, can we do it? No. We have a time limitation. We have a constraint of 4 o'clock. We can stretch it maximum by 15 minutes, not more than that. Why? Because we have another session back to back. So there is always a constraint. So even if you have infinite interest to learn, and I have infinite energy to go on speaking, teaching, and analyzing, we cannot do it. Even the laptop I'm using might crash. So maximization is not possible. There are constraints. Constraints can be the time. Constraints can be raw material availability. Constraints can be energy availability. Constraints can be the demand in the market. If I don't have enough demand, I cannot maximize my production. If I maximize my production, it will lead to excess inventory, excess stock, which will not be sold. Okay, so when you do business, you have to think of so many constraints, right? COVID-19 was a constraint. Companies could not make profit. No revenue, no demand. If there is a lockdown is the constraint, right? Similarly, here time is the constraint. Okay, so we have the time. X1 products, I'm producing X1 units of product A. Each unit of product A requires 2 hours. So X1 units, I will require 2 X1 hours. Similarly, for product A, it requires 6 hours in machine 2. So if I'm producing X1 units, it will take 6 X1 hours. Please see this carefully. So the product A is completed. Now we are taking product B. As per the given problem, product B says 1 unit of product B requires 6 hours on machine 1. So to produce X2 units, I will take 6 X2 hours. And the product B, each unit of product B takes how many hours in machine 2? It takes 2 hours. So if I'm having X2 units of product B, then the number of hours in machine 2 will be 2X2. I think you are clear till now. Now the final round, and that is, my dear friends, the constraint. Time is the constraint. So we have to see the time. So you see, for machine M1, now we have been doing things like this, horizontally, row-wise. Now vertical, now divide the entire story into 2 parts. Now the story has 2 parts, machine 1 and machine 2. Both are machines, both have a life running time of maximum 24 hours, not more than that. So just see the total load on machine 1 is how much. What is the total load on machine 1? The total load on machine 1 is 2X1 plus 6X2. And this total duration should not exceed 24. So I can write the constraint is 2X1 plus 6X2, right? Has to be less than 24. Okay. Similarly, this is for machine 1. Please see the the total load on machine 2. Machine 2, 6x1 and 2x2. So this is for machine 1, M1. And the constraint for machine 2 is 6x1 plus 2x2 is less than 24. This is for machine 2, right? And we can also write that x1 is the number of units which you are producing, x2 is the number of units you are producing for material B. So the final points will be x1 should always be positive, greater than equal to 0, and x2 is also positive, it is greater than equal to 0. So we have an optimization function, my dear friends. Please see the optimization function, right? Optimization function is given. The profit function you need to optimize subject to the constraints. Constraints are in terms of time. So you have a constraint for machine 1, which I'm underlining once again. 2x1 plus 6x2 is less than 24. You also have a constraint for machine 2, and I'm underlining it. 6x1 plus 2x2 is less than 24. Okay, I hope it's clear and you are finding it interesting as well. Now, this is not the end. Now we will draw the graph. Okay, so let me rub this part and let me retain only these two equations. And I am rubbing this part. So we are doing a comprehensive example on inequalities, on optimization. Let me carefully, yes. Okay. So we are having two lines, and I'll write the lines here once again. 2x1 plus 6x2 is less than 24. 2x1 plus 6x2. It is 6x2. 2x1 plus 6x2 is less than 24, but you know the rule is I will take 24. I will take 24 equal to 24 because we have to first draw the straight line, right? I hope you are following and finding it interesting. Okay. Parthiv, nice question. Is the chapter inequalities much hard? No, it's not hard. You can see it's interesting, I will say. It is not at all difficult, my friend. It is just interesting. You can see we are just dealing with logic. So we have this equation, 2x1 plus 6x2 equal to 24. The next one is 6x1 plus 2x2 is less than 24, but I will convert the inequality into an equation. So I will write 6x1 plus 2x2 is equal to 24. Okay, this is, I think, done. Now for the first line, 2x1 plus 6x2 equal to 24. Okay, let me draw that simple box. Also for this one, I will draw a box. Okay, box means I have to find the possible values of x and x1 and x2. Let me see if I can do it. I will draw a box here and I will write two boxes. Okay, and I will write x1, x2, x1, x2. For the first equation, 2x plus 1 plus 6x plus 2. Now, if x1 is 0, if I take x1 0, the rule is set two variables, set the first variable equal to 0, you will get the value of second variable. Step 2 is put the second variable equal to 0, you will get a corresponding value of the first variable, right? So here what we do, x1, we put it as 0. x1 is 0. So if x1 is 0, what do we get for x2? x1 0 means 0 into 2, 0. So 6x2 has to be equal to 24. So x2 is how much? 4. I will write 4. Fine. Now if I put x2 equal to 0, so I will write x2 is 0. If x2 is 0, then 6x2 is 0. So I have 2x1 equal to 24. That means x1 has to be equal to 24 divided by 2, that is 12. So I will write 12. Right? So you are happy? We have got 2 points to draw the first equation. Okay. Of course, you need 2 points to draw a line, and This is a linear equation, so a straight line has to be drawn. You need 2 points, minimum 2 points, and we have got the minimum 2 points. Now for the second equation. 6x1 plus 2x2 is equal to 24. So if x1 is 0, what do I get? If x1 is 0, then 2x2 is 24, so x2 is 12. And if x2 is 0, then 6x1 is 24, so x1 is 4. Great. So we have got the 2 lines, and now carefully I'll have to draw the lines. Okay. So I draw the vertical line. I draw the horizontal line. Okay. This is the x-axis. This is the y-axis. This is the intersecting point. This side is positive, and this side is negative, right? This side is positive, and this side, when you go down, is negative. So you have an interesting chapter later on, direction test in logical reasoning. So you start from here. If you go towards the north, upper part is north, value is going up. If you go towards south, value decreases. If you go towards the western side, value decreases. If you go towards the eastern side, value increases. Okay, that is how x-axis and y-axis work. Now let me see what are the points we have got. We have got 0, 12, 4, 0. Be very careful. I will draw 0, 12. 0, 12 coordinates means x-axis 0. No movement in the x-axis. No movement. You are wherever you are, you stand straight. No movement. Not to this side, not to this side. 0. 12 is you go up by 12 steps. So I will go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So this point is 0, 12. Okay. And now I will find out. So 0, 12 is, x1 and x2. No, 0, 4. I will take 0, 4. Sorry, not 0, 12. 12, 0. So 0 and 4. I will take 0 and 4 first. We are doing the first one. Yes. We'll take 0 and 4. 0 and 4. Sorry, 0 and 4 means no movement here. I will take 1, 2, 3, 4. So 0 and 4. The first point. 0 and 4 is done. Next is 12, 0. 12, 0 means we will move across the x-axis 12 units. It is positive, so we will move towards the east. So we will move towards the right-hand side, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So roughly this is 12 and 0. So for the first equation, let me try and draw. The line intersecting point is here and here. So let me try to draw a smooth line and just, yeah, gone. So this line represents the first equation, 2x1 plus 6x2, 2x1 plus 6x2 equal to 24. So let me write it, 2x1 plus 6x2 equal to 24, this line. Now I take the second equation. What is the second equation? 6x1 plus 2x2 equal to 24. And the point is 0, 12, 4, 0. I'll take 0, 12 first. Okay. We have taken 0, 4. Now I will take 0, 12. Okay. So 0, 12 means no movement on the x-axis. No movement. We go 12 units up. So this point 0, 12. And we have 4, 0. 4, 0 means 1, 2, 3, 4. This is 4, 0. So the second equation, we have got these 2 points, x-axis point, y-axis point. This is 4, 0. And this is 0, 12. I'll try to draw a line such that it connects this dot and this dot. Okay, I don't have a ruler, but I'll just draw a freehand line. This line which we see here is the second equation, 6x1 plus 2x2 equal to 24. Okay. Now the final point. We have to find the bounded region. Bounded region. Now you see, please follow carefully. I'm taking the first equation, that is 2x1 plus 6x2 equal to 24. The first equation. The actual inequality is less than 24. Less than means on the left hand side. So I will first draw the unbounded region for the first graph, unbounded, left hand side, and entirely I'm shading. Left hand side I'm shading, completing the shading part. Done. This is for the first. Please see the entire line left hand side. Please follow carefully. Unbounded, no, the line is infinite and the shaded region is infinite, the shadow is infinite. I have the second line again. Okay, I have the second line, 6x1 plus 2x2 equal to 24. Where is the second line? Yeah, this is the, I have taken the second line first. Yes, second line I have taken first. Now I'll take the first line, 2x1 plus 6x2 equal to 24. This is the line. So I will draw again the left hand side of it. So the line will be like this. The shaded region, shadow is like this. So on. What is the common area? Just see the common area. Both the lines are intersecting at certain points. Now the common area is this part, which I'm drawing in red, or I'm drawing checks. This is the common area. Please see this red part, the checked part. This checked part is also to the left hand side of this line, also to the left hand side and below side of this line. Okay, so 2x1 plus 6x plus 2, the red area is below that. The red area is also below the other straight line, 6x1 plus 2x2 equal to 24. Please see, very interesting point. So these four areas which you see, these 4 points, okay, if I write 0, A, B, and C, this is the bounded region. Bounded means boundary. So this is what is called the feasible region. This is the feasible region for the given problem, and this is how we achieve the solution to these type of problems. The shaded portion which you see in red is the feasible region. So dear friends, what we did was, the first step was to understand the optimization, we maximized or optimized the profit equation, right? Then what we did, then we understood the constraints. Timing is a constraint. So we understood and analyzed how much time it takes to produce X1 units of product A for machine 1 and for machine 2, right? Then second step, how many hours it takes to produce X2 units of product B, both for machine 1 and for machine 2. Okay, so machine 1 is having two types of load, burden. First is to produce product A, X1 units, and to produce product B, X2 units. So we found out what is the load. The load came to how much? The load came to 2x1 plus 6x2. And this has to be less than 24 because the machines can run for basically less than, it's basically up to 24 hours, right? Similarly, for the next equation, 6x1 plus 2x2 is less than 24. This is for product B, A and B. So this is the loading on machine 2, the total loading on machine 2 for both X1 and X2 units, that is both for product A and product B. So we found out what is the burden, the load on both the machines. This is nothing but the constraint. This is nothing but the limitation, right? Plus, we can understand that if you are producing X1 units of A and X2 units of B, that means both have to be more than 0. So X1 is greater than 0, X2 is also greater than 0, right? And then what we did, from the inequations, we created equality, okay? Equal sign, we draw the straight line. How? By getting minimum 2 points. What is the strategy for getting the 2 points? You just put X1 equal to 0, get the value of Y, X2, you put X1 equal to 0, you get the corresponding value of X2, you put value of X2 0, you get the corresponding value of X1. Same process followed for the second equation, 6x1 plus 2x2 equal to 24. We have done the same thing. We are first setting X1 equal to 0, we get X2 equal to 12. Then we are setting X2 equal to 0, we are getting X1 equal to 4. So I've got the lines 0, 4, 12, 0. So I have gone 0, 4, and 12, 0. I have drawn this line, which is the flatter line, almost flat. Then I have taken the next point 0, 12, and I have taken 4, 0, 4, 0. So now I draw the second line, which is more steeper line, steep. The gradient is more. And then I have drawn the shadow on the left hand of the steep line, and also for the this lower line, which is more flat, I have drawn the shaded area. The common part of both the lines is the solution set. Okay, so this is given by the red marked area, which means it is like a, it's a quadrilateral 4 lines, 1, 2, 3, 4. So we have 4 points, and this gives you the bounded region or the feasible region for the given problem. So it's a wonderful, problem in the Board of Studies example in page 3.6, and good that we could do it in detail. Okay. Let me take another example from page 3.10, and I hope you're finding interest in this chapter. This chapter is not so taxing as the last one. It's very easy, and just have to draw the graph and just make sure that you draw the straight lines correctly using the right points. Page 3.10, let me take 3.10, and the question is, draw the graph and the solution set. Okay, solution set of the equations. It is given x plus 2y equal to 4. Okay, and x minus y is less than equal to 3, right? So today is the last class on equations and inequalities. I think from the next day we enter into the most important chapter of mathematics, and that is the time value of money, which has the maximum weightage. There are 3 classes allotted on time value of money, and then we will do permutation and combination, right? So this being the last session on equations and inequalities, let us take up the remaining part. So we have got one equation and one inequality. So what we do is, it's less than equal to 3. So let us set it as 2 equalities, 2 equations. So let me write x plus 2y equal to 4 and x minus y equal to 3 and see what happens. So for the first equation, we create a box. Again, a box with value of x and y. For the second equation, yes, we create another box and we have x and y. Okay, fine. So now you can tell me what to do. So first you have to set x equal to 0. So I'll put x equal to 0. So if x is 0, 2y is 4, so y is 2. And if y is 0 in the equation, if y is 0, then x becomes 4. I think this is easy, and you can understand how we are getting these 2 points. Okay. And now we take x minus y equal to 3. So if x is equal to 0, what happens? If x is equal to 0, then y becomes how much? Y becomes, if x is 0, y becomes, I think, minus 3. If x is 0, yeah, y is minus 3. Y is minus 3. And if y is 0, what happens? If y is 0, then x is 3. Okay. So great, we have done the problem. Now the easiest part is to draw the graph. Okay, so again, let's draw the graph. The vertical line and a horizontal line. Okay, 0. First equation, 0, 2. Coordinates 0 and 2. 0, 2 means no movement in the x-axis. We go up by 2 steps. So 1 and 2. This is 0, 2. And the other one, so I've taken 0, 2, I'll take 4, 0 now. 4, 0. 4, 0 means move towards the x-axis positive side by 4 steps. Okay, but y is 0. That means no further movement, no vertical movement, just horizontal movement. So I will take 4 steps, 1, 2, 3, and 4. So this point is 4, 0. Let me then. Okay, so the equation goes like this. At the same time, we know that x plus y is equal to 4. So this will be the shaded region. And this is the solution to the, you can say, the feasible region for the given problem, right? So friends, we have looked at the inequalities. First is to create the equations, number one. From the equations, you draw the box, and you know that minimum 2 lines are required. 2 points are required to draw a straight line. These are linear inequalities, which means that you have to create what? You have to create equations first. From the equation, you draw a straight line. From the lines, you have to find the feasible region, which is the shaded region. So we have got x equal to 0, we have got y is 2, and when y is 0, we have got x equal to 4. So we have plotted the point here on the graph. Similarly, when x is equal to 0, y is minus 3. This is for the second equation. And when y is 0, x is equal to 3, we have plotted the same. Then we have drawn the 2 lines and we have got the feasible region, right? Now we will take the last examples before we close the chapter. This chapter is light and you can see is purely based on optimization. As I said in the beginning, we have 3 parts to the chapter. First is, from the given condition, frame the equation. Just remember the last example I took when we had product A, product B, and there was a profit maximization. So first step was we created the maximization or the optimization equation. Step 1. Step 2, we created the constraint. You remember machine 1, machine 2, maximum running time 24 hours. So we created the constraint. And the third part is drawing the graph and finding out the feasible region. So step number 1, draw the maximization equation or the optimization equation. Step number 2, find the constraints. Step number 3 is draw the graph and shade the feasible region. Okay. Now we take one small example. And okay. This is exercise 3A, page 3.13. So exercise 3A, page 3.13, number 2. Okay, the question says, on an average, an experienced person does 5 units of work, and a fresher that does 3 units of work. Okay, fine. Let me understand the question and try to create the function. So for experienced person, the person is doing 5 units of work. Okay, he is more experienced and therefore he is producing more in terms of output. So 5 units of work. A fresher, okay, so let us take a fresher. Okay. So let's take a fresher. So fresher is doing how much? 3 units of work. Fine. Okay. Yeah, there's one question from Bharani. Can you please upload the weightage of marks for each chapter? I discussed it in the first session. I will send once again the weightage to you. No problem. Okay. Jaya was asking, what is the value of the feasible region? Well, the value is, you have to find from the coordinates, right? Intersecting points. Sometimes you will get the intersecting points, sometimes you will not. In that case, you just shade the area and that will be the region. Okay. Fine. Now, let's take the optimization. The question is that the experienced person is producing 5 units of work while the fresher is just providing 3 units of work daily. But you can say 3 units of product daily, but the company, say the company is X Limited, where these two people are working, the company has to maintain an output of at least, please see the word at least 30 units per day. 30 units per day. So we have got a optimization. We have got a constraint, rather, I'll say. Okay, minimum 30 units. So I have then ideally you as a person who is experienced, he is providing 5 units of he's putting in 5 units of work. A fresher is putting 3 units of work, right? So it's a lovely question from the Board of Studies question bank, which is given in the exercises. So if there are X number of persons who are experienced, I'm writing EXP, and there are Y number of persons who are fresher, I'm writing FRESH, right? So one experienced person produces 5 units. So if I have X number of experienced person, what will be the total output? 5 into X. So I will write 5 into X. Okay. This is for the experienced person. Now we have the fresher. One fresher produces how many units? 3 units. Okay. 3 units of work. You have how many freshers? I have taken Y. So one fresher produces 3 units. So Y number of freshers will produce how many units? 3 into Y. So it is 3Y. So the total production will be 5X plus 3Y. But please see the constraint here. At least, we cannot forget this constraint, at least 30 units. So I will write that whatever you produce, okay, whatever you produce, the X number of experienced people and the Y number of freshers, whatever number of units you produce must be at least 30. So it should be 30 and more than 30, 30 or above 30. So how to express that? I will write 5X plus 3Y should be greater than equal to 30. Okay, this is the optimization. At the same time, you know that the number of freshers, experienced people is X. So definitely number of workers must be positive, right? You cannot have negative number of workers. So X is greater than 0. Similarly, Y means the number of freshers, number of people, number of persons. It cannot be negative. So Y is also more than 0. Okay, so this is the optimization function, and X is 0, X is more than 0, Y is more than 0. So the given situation can be expressed in this manner. 5X plus 3Y is greater than equal to 0 because we have a constraint that the output is at least 30 units per day, which means the output should be at least 30 means what? 30 and above. So we have used greater than equal to sign. Okay, please see the sign. It is very intelligent and interesting, and I'm sure many of you will slowly start taking extra care for mathematics because it's a beautiful subject. It's so logical, and you will see that even accounts, entire finance rests on mathematics. Mathematics is the basis. Mathematics is the foundation. Entire financial management, economics is basically dependent on maths. Later on, you will see when we do calculus, you will find that the concept of calculus will be used even in economics, right? So you see, this is very interesting, no question about it, and very scoring also from the exam perspective, because if you get the concept correct, you see the inequality chapter. I was telling many of you when you were sending the queries today that the chapter is simple. It has 3 parts. Just understand the given situation, frame the equation, right? Frame the constraints and just draw the graph. Right? Sometimes, of course, drawing the graph, you may not get a question like that, but framing the constraint, definitely you will get right. Now, let us see the last part, the last question. And this is, I will take this from, okay. This is page 3.16 exercise 2, I think. Yes, example 2. So let me take, this is an interesting question and beautiful question prepared by Board of Studies. So I will end the discussion today with this wonderful example from BOS, page 3.16, exercise 2. Okay, this chapter is otherwise very simple. I hope you can now appreciate that. Example 2, page 3.16. The question says that a dietitian wishes to mix together 2 kinds of food so that the vitamin content of the mixture is at least 9 units. Let me write vitamin A. So vitamin A should be 9 units minimum. Okay, minimum 9 units. Vitamin B 7 units. So vitamin B is 7 units. And vitamin C is 10 units, and vitamin D is 12 units. Okay, all of you remember the old when you studied about human physiology and the types of vitamins. Vitamin C, you know, creates what? It is basically, it entirely, you know, it cleans up the inner part, your internal organs, and makes it very strong. Vitamin D is good for bones, right? So yeah. So they're trying to produce a sort of a mixture, a diet which will have at least 9 units of vitamin A, 7 units of vitamin B, 10 units of vitamin C, and 12 units of vitamin D. Now, the vitamin content per kg of each food is given. So what we can do is, right, it's a mixture. So we have food 1 and food 2, right? You have the 4 vitamins A, B, C, and D. So I'll just create a table. And we have A is 2, and B is 1, C is 1, and D is 2. Food 2, we have 1, 1, 2, and 3. Okay, so we are assuming that X units of food 1 will be mixed with Y units of food 2. Okay, because the idea is the dietitian wants a mixture of 2 kinds of food 1 and 2, right? And such that, such that the combined mixture will contain at least 9 units of vitamin A, 7 units of vitamin B, 10 units of vitamin C, and 12 units of vitamin D. And the nutrition quality, right, in the ingredients of food 1 and food 2 is given in terms of the 4 vitamins, right? So now the question is, for vitamin A, very simple. How much do you need? How many units of vitamin do you need for A? You need 9, right? So if you mix, so let me assume that X units, right? X units of food 1 is mixed with Y units of food 2. It's a mixture. I am mixing 2 types of food with 2 different nutritional content. I mix it in a proportion, right? So that I get these benefits, these ingredients. So what I do is, I am assuming food 1 is given with its content, food 2 is given with its content in terms of vitamin A, B, C, and D. Clear? Following? Right? So I assume, as per to solve it, we assume that X units of food 1 is mixed with Y units of food 2. Right? Food 1 has 2 units of vitamin A. So if I mix X units, how much vitamin A will I get? 2 into X. With it, I am mixing Y units of food 2. Food 2 has 1 unit of A. So if I put Y, I get 2X plus Y. And this 2X plus Y must at least have 9 units of vitamin A. That means the equation or the inequality will be 2X plus Y must be at least 9. That means 9 and more than 9. That means 9 and greater than 9. So we have 2X plus Y greater than equal to 9. Very intelligent approach and a lovely question, I must say. And very likely for the exam. When I say it's a lovely question, it means it's a hint I'm giving you that it is very important for the exam. Okay, then we have B 7 units. Okay, so I am mixing X units for B. So if I mix X units of food 1 and for B I have 1, so I'll write X. I'm mixing Y units, vitamin B I have 1, so X plus Y, and this must be greater than equal to 7. This is the second condition. So I've done the equation for vitamin A and vitamin B is done. Okay, now we have the last two, vitamin C and vitamin D. Okay, vitamin C, you know, builds up the internal organs, makes you strong, and is a antioxidant. Yes. So vitamin C, if you mix X units of food 1, I'm getting 1 unit, so I will write X. If I mix Y units, Y for food number 2, each unit has 2 units of vitamin C. So if I mix Y units, I will get 2 into Y. So I will write X plus 2Y. But for vitamin C, what is the criteria given? Let me look. It is C equal to 10. So X plus 2Y must be greater than equal to 10. This is the third condition. And the last condition, yes, is vitamin D. Same rule, X, food 1, vitamin D is 2 units. So X units means 2X. So I will write 2X plus vitamin D for food 2. I am mixing Y units, and each unit of food 2 has 3 units of vitamin D. So if I mix Y units, it will be 3Y. So it will be 2X plus 3Y. But this must be at least 12 units as per the given condition in the problem. So 2X plus 3Y must be greater than 12. This is the fourth condition. Last but not the least, I don't need to tell you, you can tell me, and that is both X and Y is what? X is the quantity of food 1, Y is the quantity of food 2. Can they be negative? No. So it has to be positive. So X is greater than 0, Y is greater than 0. So it's a lovely question. And with that, we shall be ending our discussion on inequalities. So friends, we had a long day today, and I thank all of you for solving so many questions with me. And also many questions have come. I was asking, yes, time value of money, we will have later on, like next day, we will start with time value of money. Now, Kashish has asked, how do we shade the area? If a question comes, no, definitely the question paper will tell you the way in which you can shade. You might be carrying a ballpoint pen, you can shade with that. Of course, it depends on the type of questions. And right, so normally graphs, I think will not come in, normally it does not come in the exam. Of course, equations will come, inequalities will come, constraints. MCQ might be given that which is the right constraint, or you might get a graph also. 4 graphs are given. Which graph is the correct one for the given condition? Okay, so you may not have to draw a graph, or you may not have to draw a shaded region, but definitely you will have to you have to select the right shaded region if 4 graphs are given, right? Or you might be given a situation like this, and you may have to look at the facts of the case, mix X and Y and find out each of the equations, and accordingly 4 options will be given, right? And you have to match the right option with your answer. Okay, so friends, we had covered today the remaining part of matrices. We started with the determinants for 2 numbers, for 2 unknowns. We did 3 unknowns. Then we went into the Gramos rule for X, Y, Z, and then we moved on to the most difficult part of matrices as per my understanding, that is cofactor. Very long process, a lot of opportunity of making mistakes, but fortunately we were cool, calm, worked together, and we were able to solve the questions. So after cofactor, we went into adjoint, and then we discussed and did problems on adjoint matrix and the inverse of a matrix. Then we went into linear inequalities, where I stated that we have 3 parts to it. The first part is framing the equation from the given inequality. The second part is finding the constraints. Remember the machine, 24 hours. that is a constraint, right? Here you can see the constraints given, right? The content of vitamin A, B, C, and D is a constraint. And last but not the least, is the beautiful way, a fresh perspective when we draw the graph, find the two lines, the 2 points we need to draw a straight line, identify the 2 points, draw the straight line, draw also the shaded area, indicate the shaded area which shows the feasible region for the given situation. So dear friends, with that, I would wrap up the session. Thanks a lot for being there and working together. I thank each one of you for interacting, sending the questions, and I was able to revert back to many of the queries. And with that, see you next day when we start with the most important chapter and perhaps one of the most interesting chapters in mathematics, the time value of money. We will have 3 sessions on that. Thanks a lot. See you next day. Till then, bye and take care.